Hey everyone, welcome back to my channel. In today's video, we are going to learn about Amazon HealthScribe, an AI-powered medical documentation service from AWS that automatically converts doctor-patient conversations into structured clinical insights. Amazon HealthScribe is mainly used in three major areas. First, medical transcription, where doctor-patient conversations are automatically converted into text. Second, clinical documentation, where AI generates summaries such as diagnosis, assessment, and treatment plans. And third, healthcare analytics, where structured medical data is used for insights and decision-making. So, let's get started. As you can see, this is a demo showing how transcription and medical insights are generated from a doctor-patient conversation. Now, let's see how we can do the same thing programmatically using Python. First, go to the S3 service. Create one bucket for input audio files. I'm naming it HealthScribe Input Bucket. Next, create another bucket for output results. And name it HealthScribe Output Bucket. Inside the input bucket, upload the audio file. This audio file is a diabetes-related conversation between a patient and a hospital doctor.
Dr. Parker, what brings you in today?
Hi, Dr. Parker. So I've just been feeling really tired lately, like just having a hard time. I've been sleeping really well, but like even when I'm sleeping through the night, 8 or 9 hours a night, I just still feel really tired throughout the day. And
Make sure the audio format is FLAC or WAV, because Amazon Transcribe Medical supports these formats. Now we need to create an IAM role. This is required because Amazon Transcribe needs permission to read audio from S3 and write output back to S3. Go to the IAM service. Click on Roles. And then click Create Role. Choose Custom Trust Policy. Inside the principal, add the service. Click Next. Attach the policy Amazon S3 Full Access. Now give the role a name. I'm naming it HealthScribe Service Role. This role allows Amazon Transcribe Medical to access our S3 buckets. Now let's move to the terminal. First, create a Python virtual environment and activate it. Don't forget to install Boto 3, which is required to work with AWS services. Now create a Python file. I'm creating it using the VI editor. First, we import the required Python libraries. Inside this file, we use Boto 3 to communicate with AWS services. We use JSON to read the output file. We use time to wait while the HealthScribe job is processing. And we use UUID to generate a unique job name every time the script runs. Next, we define the configuration variables. Here, we specify the S3 input bucket name, where the audio file is uploaded. We also specify the S3 output bucket name, where HealthScribe will store the results. Then we provide the IAM role ARN, which allows HealthScribe to read from and write to S3. Finally, we define the AWS region. After that, we initialize the AWS clients. We create one Boto 3 client for Amazon HealthScribe and another Boto 3 client for Amazon S3. These clients allow our Python script to interact with AWS services. Now, we define a function to automatically detect the latest audio file from the input S3 bucket. The script lists all objects in the bucket, sorts them based on the upload time, and selects the most recently uploaded file. This makes the process fully automated, so we don't need to manually update the file name. Next, we start the HealthScribe job. The script creates a unique job name using a UUID. Then it starts the medical scribe job using Amazon HealthScribe. Here, we provide the S3 audio file location, the output bucket name, the IAM role ARN, and enable speaker labels, so the system can distinguish between the doctor and the patient. Once the job starts, the script begins monitoring the job status. It keeps checking whether the job is in progress, completed, or failed. While the job is running, the script waits for a few seconds and prints a processing message. When the job is completed, Amazon HealthScribe generates a clinical summary in JSON format. The script automatically downloads this file from the Output S3 bucket. Finally, the script reads the JSON file and prints a structured clinical report in the terminal. Now, as soon as we run the Python script, the HealthScribe job starts automatically. You can see in the terminal that it has detected the latest audio file and started the job with a unique job ID. Clinical insights. This report includes the chief complaint, the history of present illness, the review of systems, the medical and family history, the diagnosis, the assessment, and the treatment plan. So this is how Amazon HealthScribe converts a doctor-patient conversation into structured clinical documentation using AI. If you have any questions or doubts, feel free to ask them in the comment section. Thank you for watching, and I'll see you in the next video.